So I grew up in the 90s, which meant my internet was dial-up. And that naturally created this long obsession for faster and better connectivity. And years ago, I was an avid listener to the 99% Invisible podcast, where they talked about a fascinating communications network, one that I'd never heard of. So a week or so ago, I posted a poll on LinkedIn. What was the first high-speed, long-distance telecommunications network in the world? So there were a few hints in the question. First, thousands of kilometers. So we're talking vast area, certainly over the horizon. Next was the 3 word per minute throughput. Now, this makes dial-up sound fast, but instant communication is something of a novel invention. Up until about 200 years ago, messages would take days, if not weeks, and really didn't have the reliability or error handling that telecommunications implements. And when I refer to a communications network, what I'm referring to is a system that can take a message from a source and transmit, relay, or route it to a disparate destination. Additionally, it can transmit complex messages and has some level of reliability and error handling. So let's look at the results. So for the poll, I had 5 possible answers: electromagnetic, radio, optical, smoke, or animal. So let's start with electromagnetic. It's going to be the telegraph that we all know and probably some of our parents actually used. It was first invented in 1816 and commercially made viable about 20 years later with a 21-kilometer network. But the US built out their continental network by 1861. So if you want to be an operator on this network, there was a minimum standard of 25 words per minute. But there is something older than this. Now, next is radio. Marconi demonstrated the transmit-receive capability over radio frequencies to his mom in 1834, but by the end of that century, ship-to-shore communication and eventually transatlantic communication was taking over. But there's still something older than that. Now it comes to smoke. So ancient China used smoke signaling along the 7,000-kilometer Chinese wall to warn of invasions of, you guessed it, the Mongols. Now, if you grew up in North America, you would have heard that the indigenous people use smoke signals, and that is true. But it was more point to point from hilltop down to valley or village. So yes, both are old, but fairly simple messaging. Now that leaves us with optical. And for 17% of you, you got it right. So awesome. Now I was trolling a bit by calling it an optical network because, we think of optical as fiber optics. But the first high-speed communications network arguably used optics to transmit, relay, and receive messages through the network. So let's dive into the telegraph. All right, I'm trolling, but let me explain. So the first telegraph network was invented by Claude Chappe, built out in the 1790s. The Chappe telegraph was also known as the semaphore telegraph. Now, this network was composed of 500 relay stations. They were spread across France and also dipped into major economic centers like Venice and Amsterdam. This centralized hub and spoke topography of the telegraph network was based off of the Roman Empire's trade routes. And the network really involved trade, Napoleonic wars, and government communications and rule. Now, these towers dotted the countryside every 5 to 15 kilometers, terrain dependent. Now, some of these towers were actually burned down by locals concerned of witchcraft or, more likely, government overreach. This was the French Revolution after all. Now, these relay towers probably didn't look like you expected them to look. And they were composed of a mechanical semaphore on the roof, these weird things, and windows and telescopes to observe other relay towers. Now, 2 network operators would run these relay towers 365 days a year. One would watch for the other towers and take notes of the positions within a time frame, essentially the receiver, and then one would make adjustments to their own semaphore to retransmit the message down the network. These operators were sanctioned if mistakes were made, and in true telecom fashion, eventually cost-cutting measures resulted in one operator running both transmit and receive. Now let's talk about signaling. So semaphore essentially means visual signaling, and the ancient Greeks used fire, the Byzantines used water clocks, which I have not Wikipedia'd yet, and up until 1975, armies were using mirrors and sunlight as the secondary communication means. Now, Chappe's semaphore was mechanical. How it was oriented could give out a total of 98 coding combinations. 92 were usable and 6 were reserved for signal control messaging, such as resetting, retransmissions, things like that. So with 92 codes, there needed to be a code book, and this was well guarded. So the operators of the relay towers didn't have access to those code books. They were just relaying messages without any knowledge of what they were. But there were some limits. Our language is pretty complex, and with numbers, alphabets, and keywords, 92 codes were eaten up quite quickly. Just like the internet, demand for this novel communication network skyrocketed. It's because we love communicating. Even with the substantial small user base, it was limited to trade, military, and government use only. The network was getting quite bogged down. The 92 codes worked for simple communications, but having to spell out non-coded words was super time-consuming and saturated the network. So to meet the demand from trade, military, and government communications, they implemented a new system which could poorly be compared to our modern day compression. So instead of sending one signal, they would send two per frame. Again, using that term quite loosely. Signal one identified the page in the codebook, and signal two was the indexed word on that page. And this didn't double capacity. It actually almost 100x'd the capacity of this network. It introduced 8,464 codes, which could be translated to words, numbers, and letters. So to wrap this up, the French semaphore network changed trade, outcomes of war, and how governments governed. It also introduced this concept of reliable, high-speed, long-distance communications to the world and started a communication revolution. By the mid-1800s, the electromagnetic telegraph had taken over. It provided improved signal reliability, unaffected by clouds and smoke and trees, and a more efficient code, Morse code, which enabled faster transmission of messages. Telegraph went global quite quickly, wrapping the world in telegraph wiring. By the mid-1800s, roughly 10,000 kilometers of Europe was lined with telegraph cables, 37,000 kilometers crisscrossing the continental US. But possibly even more impactful is that telegraph enabled long-distance, high-speed communication to virtually anyone, exponentially changing how humans communicate. So that's it. I hope you've liked that light dive into the semaphore telegraph network. It really fascinated me and really made me appreciate the magic of communication. So over the last few months, I've been experimenting with different formats and styles as I share stories, what I'm geeking out on, and probably a few humble opinions as well. So if you'd like to see more of this content, leave me a comment, give me a like, give me a subscribe. I love hearing the feedback. It helps me incrementally improve on this passion of creating a digital portfolio. So until next time, I'll see you in the future.